Yes, good afternoon. Good afternoon to everyone. Good afternoon. Hopefully you can hear me. If you can hear me, you can say yes in the chat and we start. Can you hear me, guys? Can you hear me? Okay. I've got some yeses and yes from a couple of students. Okay. Now that you can hear me, I think we can get started. Let's get started and we pick it up from where we stopped last. That was it Friday? I think Friday last week. I don't know whether Friday or Thursday, maybe Thursday. We pick it up from our last point of discussion. Okay. Good that you can hear me. As always, when this session ends, you log back in using the same link. We've started a little bit late. I've actually run out of a meeting, a departmental meeting. So we are going to go all the way up to 2 p.m. I will not exceed 2 even by a second. So I hope since I did start on time, you managed to have your lunch. And of course, this will be a disguised kind of a blessing for those who may not have had money for lunch. Because at least you'll have something to occupy you during this. Yes, even by second, Madam or Mr. Karule, Mavis. Mavis, I'm not going to exceed even by a second. All right. So let's get started, I think. So we'll stop at 2 as soon as the session times out. As always, log back in using the usual link. Right. Okay, and maybe before I start, a reminder, we have a test on Saturday. You go to the time and the coverage will end where I'll stop on when is our lecture? Today is Monday. Is it Thursday? I think it is Thursday. So where I'll stop on Thursday, that's where the coverage will stop. Okay. All right. So and please enroll yourselves. Make sure you have enrolled yourself. Endeavor to enroll. That enrollment will end on a Friday at midday. I'm going to make sure that you get a notification, and the class coordinator should notify the colleagues. And remember the time that it will be early in the morning when our mwere is more efficient. So you wake up at around 5, you do the test. 1 hour is enough, you will be done. And some of you who are used to copying, I don't know, because some are becoming experts in that act. We will see how far you will go with mine, especially those who have mastered the art of copying online. You will sample me come Saturday, and we will see who will beat the other at the game of using securities to minimize copying versus an expert in bypassing the security in copying. So I'm waiting for your surprise in copying on Saturday. But kindly note that the exam, rather the test, will be early in the morning. Endeavor to enroll yourself very early. I see you are only 67. Those who will try to enroll themselves past the deadline, I don't know. Okay, so I beg that those who have heard, please pass the message or spread the gospel to to your colleagues. This test is the Saturday test gospel to your colleagues before it is late. Right. I think now we can get started. Yes, we had already started, but this guy Eguelo, he's saying that it is going to be the expert versus the expert. I like that. Mr. Eguelo Solomon, huh? I like the terminology or the phrase you have used, the expert versus expert. This is a confirmation that a third-year finalist is now an expert in hopping online when the assessment is done online. Good, we will see. Let us wait. But nonetheless, let's get into the content. Now that one of your colleagues has verified or confirmed that you are expert Xeroxers in online assessment. So last time we looked at Fourier series. This is what we did. I'll just quickly preview what we discussed. We came up with this function to be a representation of a trigonometrical series that we called a Fourier series. And in doing so, we went ahead and we determined the values or the expressions of an. We also got the expression of bn, and we also determined the expression of n naught. And here we used the concept or the concepts that were directly associated with orthogonality of a given set. And we also looked at orthogonal sets. And based with that background, we came and we derived the expressions for each of these Fourier coefficients, n naught, an, and bn. On finishing that, we moved ahead and we looked at some examples. I think I did one example that was sufficiently enough. After getting these expressions for the Fourier coefficients, we went ahead and we attempted example 1 here. Rather, this is now 3.4.2. We came up with these different solutions, and I emphasized the relevance of using the notation that is a compounding kind of expression. By compounding, it means it will supersede, or the other would be implications are all embedded in what you've chosen to express the series as, or the sequence. So in here, we looked at odd and even functions. We firstly computed the n naught. Here it was a direct integration. For an and bn, we used the integration by parts. We got that and we got this. All of these, I really exhausted them to the end. And this one, I told you we can write it as a piecewise function, because we observed that for all values of n are odd, okay? This would be a negative, that would be a negative, this would be a 2 over n squared pi. This one we looked at that. And this was for n odd. We looked at that. Something to use for my mouse. Okay. I'm trying to find. Maybe this one will work better. Let's see this one. Probably this is better. Okay, this was for n. This was for n odd. This one was for n odd. Okay, and then we realized that if it is n even, it will always be a 0. So this was 0 for n even or otherwise. So for n My writing pad is a little bit unfriendly today. I don't know how I will survive in this lecture. I need to get a rough surface. Oh, yeah. A moment. I'm struggling with my writing pad here. I'm not having a smooth go. Okay. Maybe this one will work better, hopefully. All right, so we looked at this, and from this, we went ahead and we said, well, we could generalize, and we looked at an example, and I told you here, one may use what I refer to as a heuristic approach. I told you we could use a heuristic kind of approach. Is that okay? So if you take that approach, then we can try to get a specific functional expression given the conditionalities that may be incorporated into this statement. And what are those? We said that if you have here, we said that you could be asked, from what we got, you could be asked to verify that this is indeed the case. So if you're asked to verify that this is indeed the case, that becomes very easy. And this was a clear demonstration of the advantage of expressing cos n pi as -1 to the n, and you express it in terms of odd and even, because it turned out that the final expression we got here, the denominator was in terms of only the n odd values. That's why you can see it is a 1, it is a 3, it is a 5, and the numerator was a 2. Why a 2? Because we had already considered the any odd, and we noticed that for any odd, this will give us a positive in between here, and that would be a 2, and that is the constant 2 you see up here. That is this one, and that 2 there. Okay, so by heuristic here is you may have to look at what you want to get, and then you will get to know there would be appropriate value of x that you would substitute into the function, and then you deal with the simplification, and in dealing with that simplification, it leads you to the desired expression or mathematical form. All right, so in this case, we had this is what we computed, and then here we are saying, since it was pi minus x, we took a try of x being 0, and in this case, x being 0 as an example. We got this, and we simplified it all the way, and we ended up with this one here. But remember, the term in the brackets, this, or rather the term encircled here in red, this is not a circle. It is exactly the term we have here in this sum here. These ones are exactly the same. So instead of writing it as that, we can just use a notation that would even cater for this dash 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 in case one wanted to see what happens with the higher orders as n increases. But from this, you can deduce that n will strictly take on odd numbers, and the numerator will always be a 2. That is what we discussed. Someone says is hearing nothing. We need some notes on this topic because nothing is there on Mwere. Oh, Some people have the notes, I think. I thought they had the notes. Okay. Point noted. This is who? This is Magezi Solomon. Magezi Solomon, you may be the only one without the notes. But I thought this handout was already there. So let me work on that after we finish the lecture. So by evening, that material will be there in case you don't have a copy. But I thought it was already there. But if it is not, then it's going to be uploaded. I'm hearing nothing. This is Betty Kukundwakwe. Now I don't know about this. Can you guys hear me? Could you say a yes if you can audibly hear me, loud and clear? Can you hear me? Just type a yes. Okay. I think Madam Betty Kukundakwe. Maybe it's probably your locality. It may be having network issues, or as always, as people say, they are always running off charge. Perhaps your phone is also outdated. You can find ways of upgrading it if you still have network issues. Alternatively, someone told me climbs the mountain, then you find a mountainous kind of scenery, climb up there, and probably the network will improve. Cosmas says he hears me, but not clearly. Apologies, Cosmas. I hope as we move through, you'll be more audible in terms of clarity. Okay, let's continue. So that is that. Someone says, how does the 3/4 come about? You man, you simplify the thing. If you don't see how the 3/4, but I don't think this man has been following, but it is evidently clear that in this step, whoever is asking about their quarter, just look at these two terms here. Do you see these two terms? The terms are there. It comes from here. Here you have pi, which is 1 minus 1/4. If it is 1, this definitely gives you 3/4. Whoever asked that question. Okay, that one is finished. Because this will go the other side, it becomes a minus. You can see here that the pi is on the left. All right, let's continue. Let's not lose more time. Okay. Whoever is asking, now there is another one asking, what about the pi squared? But you people are getting disappointed. You have pi here. You need to look at these things. Then there is a pi in the denominator here. If you factor out the pi, you have 1/pi here. It seems some of you now want to be spoon-fed. I better change the way I am handling this course. There is a pi. Please take time to look through what we are doing, you guys. There is a pi in the denominator here. So if you factor out the pi, you can see that in here there is no pi. If you take this pi the other side, it becomes pi squared. Sorry, I'm not quarreling or I'm not offended by the questions, but I am simply saying it is obvious to see that there is a pi. Some of you don't want to get your hands dirty. These things, there is nothing ambiguous in this expression. The ambiguities were how to integrate and arrive at expressions like this. And those ones I have preempted all of them. This is something very petty here. Just look at the expression, pick interest in seeing and following the solution and get yourself sorted. But the pi is obviously down here. And you're asking, where is the pi squared coming from? Have you tried to get your hands dirty by solving this thing here? I am sure the answer is no. So please, let's get more serious. Let's get more serious by looking through and probably reading through. This one we did last week, but you have not even taken the initiative to go through what we did. which is very disappointing in my opinion, because I'm just reviewing. Right, I will continue from where we had stopped. So in this case, we can now proceed. This was a review, by the way. All that I have covered here is what we did last week. I think this was Friday or Thursday. Now, continuation of this is based on the fact that now we have preempted everything to do with this section here. I must also have moments during the lecture where I take things light, or you engage a free gear. So from this part here, all the way from the beginning of this course, or rather this topic, up here, we moved and we have gone as far as this, and we have stopped somewhere here. And what remains are exercises, and as exercises I have answers. So for me, all of the things I'm going now to engage a free gear things that we have already covered. So you have this problem here for those people who are here but may not be aware of how far we have gone. And now you have this function. This one is already clear. You are moving from minus L to L. It is not piecewise in nature, so you'll integrate from minus pi to pi. You will find that your N naught is 6. You will find your Bn to be 0, and you will find the Bn to be that one. You substitute, you have the answer. That one is finished. Then you will continue. This is where you have to get your hands dirty. Fortunately, here I have given you what you should get for N naught, for An and Bn. What remains is to combine these into the series, the general form, and then you come up with this final answer. I hope I am clear on that. Right. Okay. Then there is this other example. Still, you can integrate this. Here you can see the nature of its piecewise form. From minus 2 to minus 1, this is 0. You don't have to worry about the first one because it will be 0 everywhere. Then you have from minus 2 to 0. Then you'll have 1. Sorry, this is, it will be a minus 2 from minus 1 to 0. Then it will be a 1 from 0 to 1, and then it will be a 1 to, this is 0 from 1 to 2. You don't even have to worry about this one. If you are sharp, I'm sure you have seen that. Yes, our given interval, those who are alert, we are moving from minus L to L. This is some closed interval, but this closed interval, which is equivalent to a minus 2 to 2, it is nested in such a way. Those of you who have started doing some programming, you'll understand what I mean by when I use a nested kind of interval. Or those who have programmed, you've understood what they call a nested loop, whereby the bounds of a minimal impact, given that this is 0, this is 0. So yes, this is a trickery. Given that it moves from minus 2 to 2, the reality is it moves from minus 1 to 1. This is what we have. Because the minus 1 and 1, it is between this. So I can have a small l within that big L. And this small l is simply a minus 1 to 1. Which is obvious, it will come out very fast. Yes, these ones are there, but you don't have to worry about them. Generally, you're going to operate within that domain. Okay, I think that one is clear. You see the parameters, if they exist, those people give me headache. Programmers want everything to the dot. Please get the hands dirty. There is, these ones we can now flip over. These ones are for you. Trigonometrical functions, you are the people teaching in those schools down there. By the way, never take offense when I say schools. It is because you are there, but for now you don't qualify to be there, meaning you are quacks. That's why I call them schools. When you become really teachers who understand the pedagogy, then they will become schools. But for now, I insist, you are quacking in those schools because some of you still have issues with the pedagogy, especially those who are doing education. But soon you'll be there. -2 to -1, is it by mistake for not to be 0? What is this? From -2 to -1. I think this is in the previous example. -2 to -1. It is not a mistake. What do you mean it is a mistake? This is not a mistake. I think this is well, Solomon, it is not. You have -2, you are moving towards the right, so you have -2. You have, I guess you understand, you did limits in calculus 1. I don't think, maybe you've got the interpretation wrong. This one is okay, Mr. Uguela has no problem. You move from -2, -1, 0. This has no issues. Okay, let's leave now the obvious. Go through these things. These are all yours. You can see after getting this, I told you can use a heuristic approach. Using a heuristic approach of taking x to be pi over 2. Usually this is not given. You must figure out this. What is given is you work out this and then they tell you, use the result you have obtained to deduce that this is the case. So in your attempt to deduce, that, remember this is what you've got as your answer here. Is that okay? You've got this, then the question would be, using this result, assuming this was question A, now we have question B here. Those who may be wondering what I'm talking of. So in question B, they say, use the result obtained in A to deduce that pi over 4 is equal to this statement here. And for you, I am saying you take a heuristic up. This one is not given. The one I have highlighted in blue. Is that okay? It is you to figure out this. Once you've figured it out, throw it into this, do the necessary simplification, and then you come up with that conclusion. And you say, all right, for x equal to pi over 2, once I incorporated into the result of A, it indeed becomes to what we have here in B. And that is the conclusion to that. I am sure by Saturday, you will be experts in these things. That one I am certainly. Mr. Arthur Turiakira, he asks a question. What is the criteria of choosing the X? And the answer I have said, the criteria is heuristic. Just in case you didn't get the word, I will type in again. The answer to you, Mr. I forgot the name now. What was the guy's name? Arthur Turiakira. Yes, the approach is heuristic. That is the criteria. Okay, I think I have now answered enough of the questions. So let's proceed. I keep referring to your charts only that most of the time I find they are nonsense. But today I'm finding there are things or questions or statements that are worth commenting on. Okay, So this is what we now have. Okay, these are all yours. Now these are all yours. My finalists, the experts who are going to teach the nation, these are all for you. Go and do. Quench the thirst of understanding this course. Now remember, we discussed even and odd. This one I have already told you. A function is said to be even if you have f of minus x, which is fx, and I already demonstrated this. A quick example is if you had let me take something like this. If you had the fx, which is equal to x squared, then they tell you, check out this to see if it is, verify if this is odd, even, or odd. Determine whether this function is odd, even, or neither. It may not be odd, neither may it be even. So you just use this condition here. Is that okay? So if x is negative, what happens? You have f of minus x. So where there is x, you have that, and what will this one be? This one will be minus x. The whole thing is squared. This will simply give you x squared. And what is this x squared? This x squared is the original thing, which is fx. And from that, you can obviously notice that the term here, which is in black, is the positive of the term there, this one here. And this statement in black is exactly what we have here in blue. Then for the negative, it is also obvious. If you change this one to x cubed, and for example, if you now have fx is equal to x cubed, let me just give a very simple example. This is x cubed. Okay, now prove or determine the nature of the function here. Is it odd, is it even, or it is neither of the two? And then you apply the same condition. This is the condition here. So since fx is that one, you check if it is now f of a negative here. We throw in the negative in the other one, which will be negative x now. This whole thing to the power 3 is cubic. You multiply that 3 times, it is a negative, it will give you minus x cubed. But what is this? This is the same as minus. You can see that this x cubed is the fx, so it is minus f. This is minus fx. And since that is the case, it is evidently clear that this term here in red is that term there. And these two terms merged together, they actually give you this one here. And here you can conclude that the function fx, which is positive x cubed, is indeed an odd function. Okay, these are quite direct, obvious things, really. Let's not overbog ourselves down with the petty definitions of odd and even. So you can go through these ones. This function, that function, the function, that one. Even the parameters can smile here, believe me. Then here, what do we have? Okay, Mr. Opolot here has helped me, I think, to answer Mr. Arthur Turiakira. Opolot Jorem says, you look for the value of x that enables you to get what is on the left and then substitute into the expression. Yes, given what you have said, out of 10, it would give you a 6, Mr. Opolot. The point is there. You can polish it further. So at least you're above 50%. But I still insist that what I said, the heuristic encompasses all what you have got. The answer needs some slight polishing, but the point is there. Many thanks, Opolot, for helping me clarify the answer I have given to Arthur Turiakira. Right. Okay, we are remaining with less than a minute to end this session, colleagues. As soon as it times out, let's log back in using the same link as always. And then we proceed with the properties. This will simply be a highlight of, again, something that is quite direct. And then we bring in some concepts of calculus 1, and we'll be ready to go. All right. So just log back in very fast, log back into the session very fast, because this is definitely running out almost now.